Hello. Let's see. 2 seconds. I apparently didn't mute my stream. Hi, everybody. I guess this is the day to have technical issues, but let's hope that everything solves itself. Today we're going to have Allan on, but he is currently doing some battling with these camera and stuff like that. So let's hope that solves stuff. With me, currently at least, I have April. Hey, April.
Hello.
Yeah. How's it going?
I am still exhausted from Build, but I got to meet Mark in real life at Microsoft Build UK, which was amazing. I'll let him tell the story, but he definitely got pulled into a random session last minute because someone got sick. And he smashed it and pulled it out of the bag. So that was awesome. That was really cool.
Yeah, it's always one of those things. And again, it's like the live demo gods things that keeps on happening. We at Crayon we're currently booting off tomorrow a pretty big event in Norway with close to 1,500 attendees and stuff like that. And I almost had to start creating a talk because I'm not supposed to speak there, but then someone got COVID, and I kind of got like a message like, maybe you should think about if there's anything you want to talk about. It's like a couple of days before, and like, oh no, that's not great. But luckily, at least for you guys, that solved itself, and apparently there was a pretty well run event Build.
That was the word on the street. I think the feedback from the people that were there, that was amazing. It was hybrid, so we had about 10,000 people streaming online, and then we had about 400 people in the building.
Right.
The building was packed. There was food running around. There was a donut wall. There was a lot going on, and
I
people
saw the donut wall.
Yeah, the donut wall was awesome. I didn't eat from the donut wall. I wanted to, but I was just like, if I sit here and eat, I won't actually be able to go and do my job because I'll just be sitting here and eating donuts, which is fair play, right?
I literally almost like got donuts after seeing all the pictures because there was so many people who shared a donut.
So many donuts.
So many donuts.
And they had food going around. Titan made an appearance.
Yes.
He's in the videos. We had to get special approval to get him on campus, and we pulled that out of the bag the day before and then got him on the morning of Build. Yeah, I think for me, it was amazing seeing all the MVPs. And everyone that I saw, I got to see people that are customers here in the UK that I've worked with, and I saw them, and I'm looking at them like, I know that person.
Yeah.
But I couldn't clock like how I knew them in a way. And then I saw their thing, and then the name clicked and like their name tag. And like, it was great to see him. High fives, selfies, all the good stuff.
I think that's like a post-COVID thing. That's going to be there's like the Nick event that's happening tomorrow is going to be really weird. I know a lot of people that are coming, and I haven't seen in years. Yeah. So that would be an awesome thing to do, and I'm so glad we're like semi back to normal.
I mean,
not completely.
We had an auditorium to watch the keynote in. I was upstairs doing the presentation stuff during the keynote. But we had a line of MVPs, like second row of the auditorium, and John Lunn was there, aka Johnny Chips. Yeah. And if anyone's ever seen me on caffeine or really excitable, I'm like, Johnny Chips. And Chris is like, let's go over there. And I go running across the room, and I leap over like 2 rows of like theater seats and land. I didn't plan this. I tried to land and then realized here's Johnny Chips, aka John Lunn, and like 6 other MVPs, and I didn't plan where I was going to land. So I did like a flying squirrel, going in for a hug, then going, crap, where do I land? So lesson learned. I got to meet Pete Gallagher in real life, Luz Carter, and and I'm going to blank on everyone's names, and I can remember their faces, so I feel terrible. But I think for me, like hearing all the MVPs and their stories were amazing. So we were, we had like an outline of like what topics we were covering, and then it was kind of up to us to figure out the questions and everything. And I'll give a shout out to Luce Carter, who gave an amazing discussion. And I didn't know her answers to like what she was going to say. And she talked about how learning C# saved her life. And I just thought that was incredible. And that's the power of code, right? And that's the power of community. Like someone pulled her in and said, we're going to do this and learn this together. And I think that I kind of sat there in the talking discussion interview with her, and I just kind of like my brain like stopped. I didn't know how to process that. But I think it was amazing to see how tech affects us, and then seeing the other things that the other people in the community are developing. And I think when we look at what we do here in the Azure Cloud Native group, like we're developing that community, like come learn and come explore. And, I don't feel like we're going to save anyone's life, but I do feel like we're doing some amazing stuff. So to hear how it impacts people around the globe is amazing.
It's not.
So
It's an awesome thing.
Yeah. So I would challenge everyone that's watching, like if tech has impacted you for the good, like how it has, create a little bit of back channel chat while we're waiting on Mark, and help me fill the space because it's my bedtime.
It seems like Mark has solved, or he's on the wrong camera, but I'll quickly run through the code of conduct, and then I pull Mark in. And April, if you want to go to bed, this is a good time to do
I'm going to tune in, but from not on the camera side. So I will see everyone later. Have a great evening with Mark. You're in amazing hands, and see you guys on the other side.
All right. Thank you. All right. Let's see. Code of conduct. It's basically be friendly and kind to everyone, more or less. So it's just be kind and considerate when you're chatting. People come from different backgrounds with different backstories. We never know. So try to be kind and considerate to others, and just in general be a good person. I think that's a good summary of it. Now, if everything works, Mark is gonna pop up on the stream. Hey, Mark.
I am here.
Are you here now? Good.
Yes, my computer really doesn't like StreamYard, or StreamYard doesn't like my computer, or something. But
and I right before we started, I bragged about how StreamYard works pretty well. It actually has worked pretty well for me, but apparently others have issues with that. How are you, Mark?
Yeah, not too bad. I'm on the wrong camera, so I'm not looking quite as pretty as usual. But
well, it's the content that matters, I guess. No, you look fine, and that should, everything will work out. You're going to talk about Azure Container Apps for us, which is an exciting thing, I feel. Even though I am, to be just to clarify, I am a Kubernetes person. So even though I am the Kubernetes side of things, I think this is like cool technology for people who kind of want to do that, but don't want to do that. Right?
Yeah, that's the TLDR, isn't it? Kubernetes for people who don't want to Kubernetes.
Yeah,
which is people like me.
Right. And like I said in the chat, feel free to drop any questions. Matt can't see the screen while he's presenting, but he will try to pay attention to stuff. But if thing comes up that I think fits in with where we're currently at the session, I'll just bump in and try to ask them as we go along. All right, Mark, you ready?
We'll give it a go.
All right, cool, good, thank you.
Right, cool. Right, okay, let's hit that. All right, so I'm going to be talking about Azure Container Apps, as indeed I did slightly unexpectedly at Build a few days ago. And for the purposes of the talk today, I am a developer. I'm actually an Azure MVP, but I'm on the development side of things, so my job is to write code and get it running in the cloud. And that's why I like Azure Container Apps, because it's not Kubernetes. So I'm going to be talking a little bit about pre-Azure Container Apps, what your options were for running containerized stuff in the cloud in Azure. Then I'll talk about a couple of things called Kida and Dapr, which will lead on to what Azure Container Apps actually is. And then with a bit of luck, we'll do a bit of a demo going on there after that. So first of all, here's a thing we want to run. Now, this is actually, believe it or not, a real world situation. What we've got a website, a containerized website, which is running ASP.NET. Nothing particularly special about that. It's just a normal MVC website. The only thing about it is it's not terribly busy. So ideally, we don't want to have it up and running all the time. We'd like to scale it down to 0 or at least to idle, so that we're not paying too much for it while it's running. And the more amusing bit of it is that we have a background worker process which is actually running some Fortran code. This is because it's actually a PhD project, and all the existing code for the stuff that we need to use is already written in Fortran. So, but we need to have it running at high scale because as part of our PhD, we want this to do a lot of detailed processing, and just running it on one PC isn't going to be enough. So we want to scale it out. And the question is, how can we do that? How can we hook up Fortran to become a background worker and to get instructions from the website about what it is that it needs to process, and then get that information back, and all run nice and containerized? So, the sort of things you can do at the moment. The obvious one for a background worker there is to run serverless, so Azure Functions or Lambdas or Cloud Functions or whatever, whatever you're running, whatever cloud you're running on, which is great for some of the time that you're doing it. But obviously, it's not going to run Fortran. There are no serverless platforms out there which run Fortran. Even if it was .NET, you kind of have to use specific patterns. So you have to very much build it for the type of serverless that you're running it on. You can't host a website on serverless unless you count Jamstack, which is not really the way we want to do it. And it does end up locking you to whatever platform you're on. So it'll lock you into Azure Functions or Lambda. You can't easily transfer between the two of those. Once you've picked one, you've picked it. So if we don't want to use serverless, there are things on other cloud platforms. AWS has a thing called App Runner, which is a simple way of running containers. GCP has Cloud Run, which is another fairly simple way of running containers. Problem with those is, first thing, they only scale on HTTP traffic. So if we've got something which is like our background worker, which is pulling work off a queue, it can't do that very easily. At least the Amazon version doesn't have scale down to 0, and you're still, even if you choose one of those, still going to be locked into Azure or GCP because of the way they're set up. So, of course, all roads eventually lead to Kubernetes. And, I love this slide because it tells you exactly what I think about Kubernetes. It shows you, even, just down in the bottom left there, that's all the people who are certified to help you actually run your flipping Kubernetes cluster in the first place. And they will help you choose from all the other things that are in this huge diagram of confusion. I'm a developer. I don't want to have to care about any of this. I've just got a container or two. I just want it to run in the cloud, please. And I don't want to have a full-time team running my cluster for me and trying to work out what's going on. But if you've got really good eyesight and you squint up into the top right there's a couple of things called KEDA and Dapr in the serverless section. You too, Dragon Lady. Anyway, so there's a couple of things called KEDA and Dapr in the top right, and we'll concentrate on those for now. So the first one of those is KEDA, which is the Kubernetes event-driven autoscaler. And what that does is it allows you to do serverless-style scaling in Kubernetes. So if in Kubernetes, you've got your standard horizontal pod autoscaler, which will scale your pods out based typically on CPU and memory. So the busier your pods get, the more retrospectively, the more it'll scale them out. What KEDA does is it extends that so that as well as just using CPU and memory, you can scale off all sorts of other sources of work. So queues, pub subs, database tables, NoSQL collections, Twilio SMS messages, all that sort of good stuff. And the other thing it does is allows you to scale down to 0 pods if there's no work on your queue or whatever it is at all. And yes, this is all running on Kubernetes. So you still got the potential complication of Kubernetes, but it does allow you to do that serverless style of work, but with a container. Second thing we were looking at there is Dapr. You will know a lot about this if you were watching I think it was the last session of Cloud Native, because Hugo did a whole session on Dapr. But essentially what Dapr is, it's in the Kubernetes world, it's a sidecar, but essentially it's just a process that runs next to your container. And it's designed to provide distributed application services to your container. And all that it requires is that your code can talk HTTP or gRPC. And essentially all the communication between your code and Dapr goes through that HTTP. So, as long as your Fortran code or whatever can call out to a process that's running next to it on a suitably known port, and Dapr can call back into your code and as HTTP and get a response, then it gives you all these sort of fancy things that it'll do. So it'll do service to service invocation. So if you've got 2 services running, then you can call from one to the other. It gives you state management, it gives you pub sub. It even does things like giving you an AXA model if you want. Interestingly, it also gives you observability, because obviously if everything that you're doing, to talk to your services and your state and your pub sub and all the rest of it is going through Dapr, it can record all that for you and give you a good amount of observability of what exactly is going on. So if there's an error with talking to your service bus, then that can get logged by Dapr. And of course, it will also do all the things like retries and stuff for you. So you don't have to bother with that in your code. All you have to say is, hey, Dapr, I need some state persisted. Please persist my state. And then Dapr can worry about whether that's going to be going into Redis or SQL or what have you, and deal with all the retries and stuff. And that will run on anything, like I say, because it's just a process running by the side of your container. That can run in your local dev environment. It can run on Kubernetes. It can run on your little cluster of Raspberry Pis, and anywhere you want. It can be set up. Kind of covered most of that. But you can see there's 39 providers for all the different triggers and bindings. So, for instance, if you've got a Twilio SMS that you want to react off, then Dapr can read that and send it to your code without you having to faff around with the Twilio API or anything like that. So we've got Kida, which gives us serverless. We've got Dapr, which gives us this sort of distributed application service. And what they've done in the Azure team is to stick those on top of AKS, add a little bit of Envoy in it just for the networking and stuff. And then they've taken out all the confusing bits and turned that into Azure Container Apps. So what Azure Container Apps is a very stripped down, opinionated version of Kubernetes. So essentially, all you have to do is to tell it about the application related stuff. So you can tell it that, these are my containers. That container there is going to be exposed to the public internet on port 80 or whatever. This one here is a background process that won't get exposed to the internet, but will get exposed internally. And we're going to define using Kida and Dapr, what that scales on and what, sort of what work it's consuming. All the rest of that, all the rest of it, all the rest of the Kubernetes stuff is just handled in a very opinionated fashion by container apps. So in theory, in fact, you don't even need to know that Kubernetes is under there at all. The configuration that you give to container apps is all, in theory, independent of what you're running on. So, I mean, Kida is kind of tied to Kubernetes, but if they did a version of Kida for Service Fabric or something like that, then you could, in theory, just dump container apps on there as well. At the moment, it works with any container that's exposing HTTP or gRPC. I'll talk a bit more about actual TCP traffic at the end. But the other thing which we'll love, as well as being simple, is it's really cheap compared to Kubernetes. It's got a consumption-based serverless pricing model, and even if you have a container that's always there, so even if it doesn't scale down to zero, when a container isn't being used, it's priced at idle price, which is, I can't forget the exact thing, but it's something like a tenth of the price that it would be if it was normally running. And the final thing is that because it is Kubernetes under the hood, you can actually, anytime that you decide that your container apps isn't powerful enough for you, that you actually need something that only Kubernetes can do, then you can basically take this all out, dump it onto a standard AKS cluster, and carry on with very little effort. Well, no more effort than you normally need to do to set up a Kubernetes cluster, which I'm sure Robert will find very easy, but I don't personally. So we'll go into a bit of a demo now. So, this is the thing I was talking about earlier. We've got a .NET website, which we want to have, not running when we're not using it, but then we want it to respond when we talk to it. It's going to send some messages to an Azure Service Bus topic, and those will trigger our Fortran worker process. The Fortran worker process will be using Dapr to take care of the fact that there is no, surprisingly, Fortran API for Azure Service Bus. It's also going to maintain a bit of state in a Redis cache, and it's then going to call back with its results to the API. And again, it will use Dapr to do service-to-service invocation for that, and Dapr to use to talk to the Redis cache. Hopefully that's relatively clear what it's going to do. And I will attempt to find. There we go. So this is my process here. This is my code here. So I've got essentially a bicep file here, which is going to declare, that's my infrastructure as code for those who are not too Azure-y, but this file here is defining what goes into Azure. And then I've got the .NET website here, and I've got a Fortran background process there, both of which have a Docker file in there to be able to build that up and turn it into a container. So this is all you need to do to set up that whole system. So, up here at the top, we just got the standard Azure stuff. So we've got a container registry, we've got our service bus queue, we've got our Redis cache, and then we've got log analytics and application insights, which we're going to connect up to everything. So this bit here is where we start with the actual Azure Container Apps bit. So the first thing we create is what's called a container app environment. That's basically your AKS cluster. And at that level, we're defining where we're sending our logs to, so our log analytics that we set up before. We are defining a couple of things in Dapr. So here we're saying that we have a thing that we're calling worker queue, which is actually an Azure Service Bus. And these are the connection strings that we need for it. And then also we're defining our Redis cache. So same sort of thing. We're saying this is our state and it's going to be a Redis cache. And down here we're defining what our host name and password are for that Redis cache. And that's all that we need for the actual environment. And then within the environment, obviously, we have our two containers, which are our .NET website and our Fortran worker. So here's the website. So again, we're just telling it which container app environment we're running that in. We're telling it where our container is and what our environment variables are going to be. So just a little bit of configuration there to say which Dapr queue we're talking to. And then here is our KEDA section. So we're saying that we want to scale between 0 and 1 on an HTTP scaling rule. And for the sake of argument here, we're saying if we've got more than 100 concurrent requests coming in, then that's when we decide that we need to scale up. So if we wanted to have 10 replicas there, then we could scale the website out to 10 if we wanted to, 10 instances if we wanted to. And then here we've just got our Dapr again. So we're saying that we're going to listen on port 80 for things coming in from Dapr on the HTTP or gRPC thing. And we're going to say here that we're actually going to be an externally exposed on port 80 to the outside world. Now, obviously, a container apps is going to wrap HTTPS around that and SSL around that. So, SSL traffic will come in proxy through to our port 80 there. This is just saying that we're always going to use the latest version of the container and all the traffic will go to that. It actually has stuff in for A/B testing, so we can, in theory, have more than one revision running and say we want to put 10% of the traffic onto the new one and 90% onto the old one if we want to. If we're not quite sure whether we want to use the new version of the container completely. And then just the secrets here and the container registry for where our container is coming from. So, a fairly simple thing there. Just container scaling rule and our ingress and Dapr configuration there. And then the same with the worker app. Again, container image. This time we're scaling between 0 and 10 based on an Azure service bus. So what it's going to do is to look at the peek at that service bus, see how much work is sitting on it, and scale out our container up to 10 replicas as necessary. And again, just a little bit of configuration here to say which one we're talking about. And again, Dapr is going to talk to us on port 80, and in this case, we don't have an ingress because we're an internal service that doesn't need to talk to anything. And that's pretty much it. So that's all that we've had to do, and that's all we need to do to set up our Kubernetes environment or our container app with a couple of containers that do serverless scaling and the website and all the rest of it. Just to show you a bit of the code here as well, just in case you're interested in what's actually going on. So this is the .NET one. So here, when we're publishing events to Dapr, all we're actually doing is pulling in the Dapr client NuGet package, and then all we have to do is to say publish event. So we're not having to worry about where we're actually publishing to. Dapr is already configured. We've already configured it to say we've got this service bus queue. So all we have to say is the name of the Dapr service, the name of the topic or queue that we're going to use, and what's in the message, which in this case we don't actually care because we're not doing any real work, but we could send something more through to that. And then there's just a couple of API endpoints down there, one of which we'll get called back to from later on from the worker app. And we've got the little HTML and JavaScript file here, which just calls through to those and tells it to start and stop sending messages. On the worker side, more amusingly, this is our Fortran thing. And the way I'm doing the Fortran thing is, if anybody's old enough to remember CGI, any web server can, in theory, pick up any executable file and call it and pass it through the information that came through as part of the post request or the get request that was sent to the web server. So in this case, we've got this Docker file which is based on based on Apache, and in there we've got a few things set up so that we can pick up our CGI bin worker there, and we've also got a little proxy just to make the networking work properly. But basically, we can then pull out the request, which in this case will be Dapr sending us through a message, and then down here to actually call out to Dapr, all we're actually doing, because Fortran doesn't even have an HTTP stack, is to shell out to curl and use that to talk out to Dapr. So we can then, in this particular case, we're just incrementing a counter in Redis, but we could do more complicated things if we wanted to. And then at the end, you can see here we're calling through to the ACA demo web app on the throughput endpoint. So that's our service-to-service invocation going through there, which is where we're telling the website that we did some work. Feel free to ask questions in the chat if that's not entirely clear and if you care about what's going on there. But again, this is fairly simple. Talking to all those things, just using the power of Dapr there, and because we've got Kida in there, this worker will scale up and down as necessary based on the amount of work that we fired at it. Right, so. So this is what ends up being deployed into Azure. So we've got our application insights, we've got our log analytics, we've got our Redis, we've got our service bus, and then we've got our container apps environment and our 2 container apps. So we can have a quick look at those. So the container app environment is here. And as you can see, it's a pretty simple thing. There's hardly anything we need to look at or set up here. There's this little section here for our Dapr components. So we've got our sort of our configured Redis connection, our configured service bus connection, and then within that we've got the actual apps. And again, we can drill in here, and there's not a huge amount going on here either. So we've got authentication, which is actually using EasyAuth. We've got our secrets, which you put in. We've got our ingress. So if I have a quick look at that, you can see that we can define on here whether we're going to be externally available or not, and if so, whether we're accepting traffic from outside the container app environment or inside. We can set up custom domains if we want, and then again here we can go in and look at the Dapr setup. And down here as well, we've got the scale side of things. So this is where you can see what we've set up for the Kida side of things. And in the revision management, excuse me. Come on, wakey.
Looks like it's taking a little bit of time.
Are we there? Oh, we're there.
Yeah, I was just about to say, like, for while we're waiting, if anyone has any questions, it's a good time to post.
I was just trying to work out whether I'd lost the internet entirely and whether I'd lost you lot, or whether it was just.
No, we still got you. It's all good.
Okay, so yeah, you can see here. This is what I was talking about. You can, it's a bit like if you know app service, you've got your slots, and you can, sort of wait traffic between your slots. Here you can potentially have more than one revision and wait your traffic between your revisions. And that's pretty much all. Again, there's not a lot to see here. One thing I can show you, if we go to the worker app, we can show you the metrics here. So again, what I can do here is I can set up a thing that shows me the replica count. So if I take that to the last 30 minutes there, then at the moment, we have no replicas of that worker app running. So what I can do then is to actually load up the website, and with a bit of luck, if I hit start sending messages there and wait a short amount of time, then we should get some throughput going through it. And I promise you this was working earlier.
Yeah, again, just like I said earlier, we there's like a demo god thing happening today.
Oh no, there we are. Something's happening. Something's happening.
Awesome.
So stop again. Yeah, we've got some messages going through there, and in theory, so hopefully, if we refresh this, we should soon see that sort of that sort of worker app there has scaled up to more than 0 instances.
So what I like about this is that it's like I mentioned in the chat, it kind of depends on where you're at. Where do you do your work? So for instance, as a developer, in this case, yes, Kubernetes is kind of like hard to deal with, but everything that you're mentioning right now is stuff that I would help people implement on Kubernetes.
Have some replicas scaling up there. Yes, it's very much sort of if you need Kubernetes, you can do Kubernetes, but for a lot of the standard stuff that's going on, this should be all you need.
Yeah, it's like what I keep on saying, that is like if you want flexibility, it's usually harder to implement, and vice versa. So me as a person who actually creates platforms, which this is literally the things that I create. Selecting tools, selective things, and implement it in such a fashion that people can just say, I just want to put this on this platform, is literally what I'm what I'm
sure you have your own opinionated way of setting things up the way you like them.
It would be really hard for me to use this to create platforms, if that makes sense. But again, if you're a developer and you just want your code to run, this makes sense. We have a question here.
Yeah, I was just Andy was asking how bicep gets applied. Well, there's a number of ways you can do it depending on what your DevOps system here is. The way I actually do it, I just have a little PowerShell script here. So that says deploy that bicep file to Azure. That's essentially sort of doing a Terraform apply there. The main difference between Terraform and bicep really is that because Terraform has the state file, it will allow you to delete things, whereas bicep at the moment at least only allows you to do an incremental apply. So you actually have to go in and manually remove anything that is no longer in the bicep.
Yeah, and that's one of those things, and this is a totally different subject. But as a Terraform person, that's one of like the main key things that I see that is missing in a lot of these things. Is people say like, oh, we don't have to deal with states. It's so handy. It really has saved me in a number of ways, in a number of times, in a number of scenarios. The fact that that's something people want to get rid of, I can't understand. But again,
but mostly bicep would use, or if you want to call it, would use the actual reality of what's in Azure as its state. It's just that one little thing of not knowing that things.
But then it won't know that it has created this, so it can't get rid of it.
I'm assuming that at some point they will actually address that in some way in bicep. But for now, that is definitely.
It would make sense.
Just a Terraform. So that's probably a good time to just sort of pop back to here. That's basically the demo there. But yes, some of the things that we didn't look at in the demo. there is actually an Azure Container App extension with the Azure CLI. So that allows you to do all the stuff we were doing in Bicep, and sort of at the CLI, so you can do all that configuration just using CLI commands. There's also a little thing called Azure Container App Up, and what that will actually do is, if you just tell it where your code is, then you can, in a single command, deploy that code to a container app environment. So that's a very easy way of getting it going. And it also has a thing, Azure Container App Logs, which allows you to directly pull out, to the terminal, the logs from your various containers.
Yeah, we got a question about when you run the Azure CLI commands to deploy AKS, it sometimes takes a while
to initially deploy AKS.
Yeah. And
our Azure Container Apps pre-provisioned. I can tell you they do provision faster than AKS, certainly. So I assume there is some amount of pre-provisioning going on behind the scenes. I mean, I don't know exactly how they do that.
So the way that I will imagine it, because I actually don't have it, I don't know. But the way that I imagine this is that what actually is happening in the back end here is there are Kubernetes clusters at the ready to handle some of these things. It takes a while to find the place to put it, but that's less time than actually deploying a virtual machine scale set and doing all the cluster provisioning that happens when you're doing AKS. But then again,
in the same way as if you run an Azure function, you don't need to wait while it provisions VM, the VMs behind the scenes for you. They're just there already.
And at that point, it depends on what you're actually trying to do. Do you need something like this very second? Then you probably should do, deploy something that can handle that if it's functional with like preheated workers, or if you or actually run Kubernetes and have that at the ready. As long as you kind of abstract away the platform, it's gonna take a little bit of time, but probably not a long time, right? When you say
obviously, the first time you fire one up, it does take an amount of time to provision the environment, but certainly not as long as it takes to provision an AKS cluster. And again, once you've actually got it provisioned, then all you have to do is throw containers at it, and even if it's down to zero, the actual deployment time is still very quick. It's not having to recreate a cluster, even if it's scaled down to zero. So it is certainly quicker from that point of view. So think cold and warm start for serverless, and you're not far off. There's the Azure Container Apps CLI there. You can also do custom domains. So we were just using the built-in DNS name there, but you can use your own domain names. What they don't have yet is managed domains. So you can't do like you can in App Service just yet, where you can just say, okay, here's my DNS, and I'll configure my DNS for you, and you handle all the certificates for me. You don't have to bring your own certificate at the moment, but they have promised that that managed certificates will be coming soon. It has easy auth built in. So again, if you're familiar with App Service, you'll know about that. But essentially, you can use easy auth, which sticks another sidecar container in that allows you to authenticate using any OAuth thing. So Google login or Microsoft login or your own custom login, and then passes through in the HTTP headers the tokens and what have you, and user information that you need to actually know who it is who's accessing your app. You can now mount volumes, so you can mount an Azure file share as a volume onto your containers. It supports health probes, so if you have a health endpoint on there, it can keep an eye on that and restart your container if it goes wrong. And the one I'm looking forward to is on the roadmap. They do actually have TCP support. So at the moment, everything has been the stuff we were doing there. Everything was talking HTTP, and we were, for instance, having to use an Azure Redis resource there to do Redis. But once they got TCP support in, obviously all we need to do is just drop in a Redis container into there, and use our use TCP to talk to that, and we won't even need to have potentially any of our resources in Azure. We can have that all within the container app, all living there as containers, and nice and easily shiftable to a Kubernetes cluster somewhere completely different, somewhere in GCP or whatever. So that I'm hoping to look for. Question there from AMX. So yes, so beside the simplicity of Azure Container Apps compared to Kubernetes, what would be another good use case? This question: is there a good use case for Kubernetes or a good use case for Azure containers? I think the thing I like about Azure Container Apps, apart from the fact that it's easy to set up, is because it's all it's another example of a highly managed service. So I don't have to worry about, for instance, when the new version of Kubernetes comes out, going through all that stuff of updating the version of Kubernetes and remembering to do that myself and worrying about whether it will break anything. That's all handled for me. The security is all handled for me. So whatever the current best practices are should all be in there already. So again, I like managed services. I don't want to have to worry about anything that I don't need to worry about. And being a skinflint, I don't want to have to pay somebody else to worry about it for me either. So if I can get all this for free, and like I say, it's a darn sight cheaper than running a full AKS cluster. So if I can get all this for free and it makes my life easier, that's why that's what I like about this sort of thing.
Is I think if you're doing things like microservices and all those kind of like modern ways of creating services and products and so on and so forth, but you don't have that platform team that's building your application platform for you, it is easier to just use app services instead of trying to force Kubernetes on people. Because this is one of the things that I talk a lot about, is like you have the idea of autonomous teams and everything like that, and then you have only like front-end developers doing front-end, back-end security, infrastructure, and so on and so forth. And it's like people, they just crammed a lot of things, and get a lot of things on their plate that I really shouldn't need to think about if they selected a job doing only a certain area of it.
Yeah.
So yeah, I think this is a really good alternative to Kubernetes if you want that platform, but without actually having to deal with that platform.
So yeah, I mean, essentially yes. This leads on to the summary slide here. So yeah, it is Kubernetes, but easier and much cheaper. And like we were saying, it's designed for microservices and serverless. So it's not like an app service for containers where you've only got one container in there. And it's not like a raw Kubernetes where you have to decide how you're going to do your microservices and serverless things. It's all out of the box. And, for me, I would say, about 90% of, standard stuff that you're deploying out there could go onto Azure Container Apps either now or pretty soon. I mean, now that it's GA, it's pretty much ready to run, and they've got most TCP and things on the roadmap to handle a lot of the remaining 10%. And like I say, the other nice thing about it is that because it's sitting on Kubernetes, you can be fairly confident if you hit the 5%, 10% case where it's not going to do what you need, then you can pretty much pick it up and move it to Kubernetes with relatively little effort. If you just set up a couple of short links there to information on container apps and Kida and Dapr. And there we are. That's all I've got to say. So we'll take any questions that you haven't already fired through.
Thank you, Mark. Really good summary of container apps. Again, a technology that I knew existed and I kind of knew how it works, but I again it's one of the things. There's a lot of things coming out in Azure. It's kind of hard to pay attention to everything, especially if you don't work with that. So it's really good to have that have that run through.
Bjorn Eric says, so I don't need to worry about all the queue control commands if I run container apps. Yes, in fact, you can't queue control it even if you want to. It's, the fact that it's Kubernetes is entirely hidden from you, apart from the fact that, you can see occasional things in container logs and stuff. Yeah. So, as I said, in theory, they could make this whole thing run on Service Fabric if they had a version of Kida that ran on Service Fabric. So, yes.
I think of this as this is the perfect use case of Kubernetes.
Yeah,
this is literally what Kubernetes is built for. It's a platform that you can create platforms on. Yeah. It is that foundation which you then add a little bit of tool A, a little bit of tool B, and you deliver that to your developers, and they can use that platform. This is literally the best use case for Kubernetes ever, which is kind of funny. So.
I actually got on LinkedIn, somebody, slid into my LinkedIn DMs the other day and was trying to pitch their product, which is basically they said, have you heard about our cloud? And what their cloud was a set of services running on Kubernetes. And the idea was that you would use that. You wouldn't program against Azure or against AWS or against GCP. You would program against their abstraction, which was running on Kubernetes. And so essentially you would then run Kubernetes on Azure or on AWS or on GCP, but you wouldn't care about it. Everything you did would be this platform running on Kubernetes. So yes, it's ideally for most of us, Kubernetes should end up being an implementation detail, and that's where a lot of this stuff is going now.
And again, if you don't have that team, and if you don't have that in-house knowledge about Kubernetes, it is kind of hard to get started. I understand that, even as a person who actually are a big fan of Kubernetes and it uses it daily. I understand that, and I have to work with a lot of developers, and it's usually those kind of things where, as you start explaining these things, people kind of go, oh, okay, well, that does make sense. But it's really hard to get started with it because you kind of see it as this giant thing. And I just want to put my stuff in there. How do I do that? And it's oh, well, you got to learn about this thing and you got to learn about that thing. But it is actually kind of easy. But again, it depends on where you're working. What is your angle? Are you a developer and you only care about developing code and put it out there? Then it's kind of hard to care about Kubernetes. It is understandable.
Yeah, I mean, people like you and Richard are not going to be out of a job anytime soon, but your work will probably get more interesting because you'll be dealing more with the.
And every day we get great examples of how to use Kubernetes for something, and in this case, it's literally built a service to have a. The thing that people kind of argued about when it said AKS doesn't manage Kubernetes service, and people go, but I still have to do Kubernetes. How is that managed? And it's but at the same time,
you have to explain that. Right. First, go and get a pile of VMs, install Kubernetes on that, and then come out to AKS, and you'll understand just how managed you already are.
Yeah, and I know Microsoft talked about it as the AKS public office hours. There's we understand that the people kind of complain about this is not a managed service, but then again, if we can't take away that because people like me who want to use Kubernetes but don't want to deal with this clustering things, we get a lot out of AKS. So it's kind of that balancing act, and which is probably why they started creating container apps, which is exactly what people wanted, but it's built on Kubernetes, and they still have a Kubernetes service.
Sliding scale of managed, how managed you are.
Yeah, and I think now we literally have filled the entire view of from unmanaged to managed in every single aspect now with all the services that are available. It's kind of funny to see how much alternatives there are and how they usually are just the same thing underneath, just different.
And of course, Azure Arc now as well, which is starting to run Azure platform services on Kubernetes on your premises. So it's all getting
yes. So yeah, it's app services on top of Kubernetes, on top of VMs, on top of et cetera, et cetera, et cetera.
Containers all the way down.
Yep. Just as long as containers, I'm happy. If it's containers, I'm not going to complain. I don't see any other questions. And if not, then great. Thank you, Mark. Like I said, this is a great run through and a great show of what app container apps are and how to use them. So thank you so much.
Feel free to hit me on the interwebs if you get any questions afterwards. Mark XA on LinkedIn, Twitter, just about everything really.
Right. Cool. Thank you so much, and thanks everyone for showing up and talking container apps with us.
Yeah, cheers,
Bye.
everyone.